We're going to have a go at filling in this table to investigate the product rule when differentiating. So we've got some functions listed there in the left-hand column. What we're going to do firstly is to expand them. So if we expand out this first one, we would get x squared, then we'd get minus 3x plus x minus 3. So that would simplify just to be x squared minus 2x minus 3, which maybe you would do that in one line. Then we would differentiate that. So dy dx would equal 2x minus 2. We should be pretty good at doing that by now. So that's what the derivative is. And then in this final column, we're going to rearrange this dy dx, but we're going to rearrange it in terms of the two brackets that were multiplied together at the start. So that was x plus 1 and x minus 3. And if we just put an addition in the middle of those, we can see that x plus 1, x minus 3 gives us 2x minus 2 as required. So just by adding those two brackets that were multiplied together, we get that. So let's move on to the second one. If we expand this out, we get y equals x squared minus 2x plus 4x. So we get plus 2x in the middle and minus 8. Move on to the derivative, dy dx. If we differentiate that, we bring down the power, so we get 2x and then plus 2 this time. If we write down the two brackets that we started with, x plus 4 and x minus 2, and add them together, we can see we do indeed get 2x plus 2, which is equal to the derivative. Okay, let's take it up a notch. This time we've got two brackets multiplied together, but there's a coefficient of 2 there, which is possibly going to make things slightly different. So when we expand, we get 2x squared plus 6x plus x plus 3. So 2x squared plus 7x plus 3. We differentiate dy dx and we get 4x plus 7. We do the same thing. We start with the two brackets, 2x plus 1 and x plus 3. But this time when we add them together, it gives us 3x plus 4, which is not what we want. Okay, but what we notice is if we put a 2 in front of that bracket, we would get the 2x and 2x, which is 4x, and we'd have 1 and 6, which would give us 7. So that does give us the 4x plus 7 by putting that 2 in front of the second one. Okay, we'll do one more. When we expand this one out, we get y equals 6x squared plus 4x minus 3x minus 2, which is 6x squared plus x minus 2. When we differentiate that, we get 12x plus 1. Writing out the two brackets as a sum, by adding them, we would get 5x plus 1, which is not what we want. But what we notice is if we put we have to do a little bit of thinking for this. It's not always easy to spot, but we're going to spot a pattern. It will become easy eventually. But for now, you're just going to have a little play. In order to get the 12x, what I notice if I put a 2 there, that would give me 6x. And if I put a 3 there, that would give me another 6x, which would give me the 12x. It also, in this first bracket, will give me minus 3, and in the second bracket will give me positive 4. So in total, it will give me the 12x plus 1. Okay, what we've got to try and spot is how did I know to put a 2 there? How did I know to put a 3 there? Where did that 2 and that 3 come from? And we've got to try and spot the patterns. But for now, I want you to have a go at filling in the table that's similar to this in your books. and have a play at that final column, and then later we'll figure out what the rule is for differentiating products like this. Okay.